The story of the Tokyo Institute of Technology is a tale of scientific discovery. Generation after generation of inquiring minds have bequeathed a growing heritage of valuable technologies. Tokyo Tech is Japan's leading university devoted to science and technology. Research and education at the university cover a comprehensive range of disciplines. In every discipline, Tokyo Tech faculty members and graduates help advance the frontiers of understanding. Tokyo Tech has a lot of important strengths, but it is especially strong in material science. The university has a long tradition of advances in ceramics, metal, and plastics. We've received a lot of attention recently with breakthroughs in superconductive iron. Magnetic materials are not supposed to become superconductive. I was looking for magnetic semiconductors. Instead, I stumbled onto superconductive iron. That could raise the temperature level at which superconductivity is possible. Our discovery of electrically conductive cement has also attracted a lot of interest. We noticed that electricity was passing through in an experiment, and that made us wonder if the cement could become metallic. If it does, then even superconductivity becomes a possibility. Truly useful technologies always arise from truly original concepts. Coming up with genuinely new concepts is the role of universities. In the late 19th century, the German scientist Gottfried Wagner introduced new technology that contributed greatly to Japan's growing pottery industry. Tokyo Tech nurtured the art of ceramics as well as the technology. The world-renowned potters Kanjiro Kawai, Shoji Hamada, and Tatsuzo Shimaoka all graduated from the university. Another traditional strength at Tokyo Tech is architecture. Architecture is an amalgam of science, engineering, design, and art, so it evokes the university's core competences. Several prominent architects have studied and taught at Tokyo Tech over the years, and the university's campuses feature some of their signature creations. Faculty members and students explore the social and environmental context of structures, as well as the aesthetic criteria. At Tokyo Tech, we are broadening our research perspective, and we are tackling issues of broad social concern. That includes seeking ways to protect the global environment. Photovoltaic cells are part of the solution. And in my laboratory, we are working on first, second, and third-generation solar cells. First-generation solar cells account for most of the solar cells in mass production. So our work on them centers on joint research and development with manufacturers. Second-generation solar cells are thin-film devices that greatly reduce the cost and the energy requirements in manufacturing. We are working on technologies for maximizing those benefits. The third generation of solar cells will improve energy conversion efficiency. Those solar cells are still under development, and we participate in a consortium of companies and universities formed to commercialize these technologies. Solar power has the potential to make a big contribution towards meeting the world's energy needs. We at Tokyo Tech are doing our part to help fulfill that potential. The Office of Industry Liaison oversees a large and growing range of interaction with the private sector. It coordinates joint research and mediates the licensing of intellectual property. Tokyo Tech's supercomputer, the TSUBAME grid cluster, is a Japanese leader in high-performance computing. It facilitates interchange in research and education among several organizations in the public and private sectors. technology is everywhere, and a lot of that technology originated at the Tokyo Institute of Technology. Tokyo Tech is a world leader in science and engineering. The university has spawned countless inventions and discoveries since its founding in 1881. Technologies born or refined at Tokyo Tech contribute greatly to enriching life for people everywhere. Tokyo Tech has 3 campuses in Japan: Okayama, Suzukake-dai, and Tamachi. Students and faculty proudly carry on the university's tradition of scientific and technological creativity. They also carry on the Tokyo Tech tradition of international perspective. More than 10% of the students at the university are from outside Japan. Mathematics is theory. Science begins with theory and proceeds to experiments. Mathematics is the language of science. It's like a language in process for people. To do mathematics, all you need is a pencil and paper. Mathematics is a fantastic world of infinite possibilities. Tokyo Tech also has excellent non-science classes. Students take liberal arts classes to complement the science and engineering curricula. Experiments are the key to progress in research. Tokyo Tech is a research university of world-class standing. Advanced facilities and a stimulating research environment support advances at the leading edge of scientific inquiry. My research group studies synthetic organic chemistry. We combine carbon with oxygen, hydrogen, and just a few other elements to create compounds for pharmaceuticals, liquid crystal displays, and other applications. All of this takes place, of course, in the realm of nanometer dimensions. So we kid about building things with nanoblocks. Tokyo Tech. My research group is working on small satellites and on high-performance devices to use in space. Every summer, we go to Nevada to conduct experiments with a small CanSat satellite named CanSat. The project is valuable experience in practical engineering. It prepares us to make real contributions to space development. Tokyo Tech has collaborative relationships with about 200 universities in nearly 40 nations. It maintains offices in Thailand, China, and the Philippines, which coordinate joint work in education and research with partner universities. State-of-the-art telecommunications technology supports distance learning via satellite. Tokyo Tech conducts a dual-degree graduate program with Tsinghua University in China. That program allows students to earn degrees from both universities. More than 10% of the students at Tokyo Tech are from outside Japan. Most of those students study in Japanese, but the university also offers several programs that allow for studying in English. In addition, students from Tokyo Tech venture abroad for study and research through a variety of international exchange programs. My name is Zaki Primadani. I'm from Indonesia. I graduated from Tokyo Tech's Department of Electrical and Electronic Engineering in 2007. Now, I work for a Japanese company and design information storage systems. Tokyo Tech has excellent ties with industry, and that helped me a lot in finding work. I went through the same job hunting process as Japanese people, such as attending explanatory seminars, meeting recruiters, taking exams. Then I got a job offer. Several graduates of Tokyo Tech fill important positions at my company. Tokyo Tech's Core Clinus Club has won a gold medal more than 10 years in a row in a prestigious national competition. Extracurricular activities enliven student life at Tokyo Tech. The university sets aside Wednesday afternoons for students to participate in the extracurricular activities of their choice. The Meister Club is for students who love making things. Meister's members create human-powered airplanes and solar-powered cars. Thus does the tradition of innovative creativity continue to thrive inside and outside the classroom and laboratories at Tokyo Tech.
Our mission is to make further contributions to the international society on solving the confronting problems such as energy resources, protection of global environment, water management, and food prices by our lively research power of science and technology. Nurturing highly motivated young scientists and engineers is of course essential for this mission. We are the #1 science and technology university in Japan. Then let's be ambitious to climb up to the world top level.